Nope.
2.
What's anything to the 0 power?
2.
1.
Oh.
Anything to the 0 power is 1. Okay, now if I do 2 to the first power, if I'm plugging 1 in for x, right? What's 2 to the first power? 2. What's 2 to the second power?
4.
4. What's 2 to the third power?
8.
8. Fill in the rest of the numbers on those tables, and then let's go backwards.
That's all the numbers.
Okay, well, fill in those numbers on the table that we just did. Okay? So 0. If we have our coordinate points, I have 0, 1. That is this point right here. 0, 1. I have 1, 2. That's this point. I have 2, 4. I have 3, 8 is that point right there. So all those blue points I have graphed on my table here. All right, real quick. This is the tricky part. I have -1, which means 2 to the -1 power. Ready? Do you know what happens to when your exponent is negative? We've done this before.
You divide.
Reciprocal.
Yeah, you can, like this is over 1. I can flip it and make this 1 over 2 to the +1 power. What's 1 over 2? Half, 0.5, yeah? Okay. This is 2 to the -2 power, or 1 over 2 to the +2 power. What's 2 squared?
4.
4, so this is 1 over 4, which is 0.25. And the same thing here. This would be 1/8, right? Which is 0.125, okay? That's where they're getting those decimal numbers from, all right? You can plug them into your calculator if you want to, but it's going like this, okay? Here is some things that you should notice. Put this off to the side. Exponential functions. The y-intercept equals 1, okay? The y-intercept is equal to 1 right here. Can you see that yellow?
Yep.
Yes. Okay, that place is always going to be 1 unless we move him around. I'll show you that here in a second. But that spot where he crosses the y-axis, the y-axis is right here, he is always going to cross at 1 until I start moving him around. Because anything to the 0 power is 1. He's going to touch at 1. So if this was 3 to the x power, let me go back. If this is 3 to the x power, guess what? He's going to have that same dot there. If he's 4 to the x power, he's going to have that same dot there. If he's 17 to the x power, he's going to have that same dot there. This next dot is not going to be at 2. It's going to be at 3 for this one. It's going to be at 4 for this one. It's going to be at 17 for this one. But they're all going to cross at 1 for an exponential function. Okay? That's how he works until we start moving him around. Okay? So they say the domain, the range, the y-intercept. We have already found the y-intercept. He is 1. Put that up there at the top. That's your y-intercept. Okay? We need to do domain and range. Domain, range. For this function, he's going to go like this and go like this. Okay? Your domain is left and right. He goes left and right forever. So he's going to be all reals. Okay? That's my exponential function domain. Now, range. Before we do that one, let me talk about this guy. He does not go down forever. He levels off, and he has what's called a horizontal asymptote. Have we talked about asymptotes before? Nope. He is a horizontal asymptote. That's how you spell asymptote. It sounds like a naughty word, but it's not. Asymptote. I call it a ha sometimes because I don't want to write out horizontal asymptote. Okay? Now, this horizontal asymptote is crossing at y equals 0. That's where the ha is. He's at 0, and he's going crossed through the y-axis. So y equals 0 is the ha. Yeah? Y equals 0. That's my asymptote. I'm putting that up there, and there he is. Okay? Now, that can help us figure out the range. Range is up and down. He won't go down forever, but he will go up forever. So, y's are greater than. Will he touch 0? No, so just greater than 0 for your range, okay? We've got domain, we've got range, we've got y-intercept, and the end behavior. Ugh. Oh, gosh, I should have put it down here.
That's what I was just saying.
Domain, whatever. Domain is all reals. Range, y is greater than 0. Asymptote, y equals 0. By the way, your range and your asymptote should always be the same number. The y-intercept, what was the y-intercept? 1, because he's always going to go through 1. Okay, and then end behavior. As x goes toward negative infinity, what's he doing? What's x going toward negative infinity? Which direction is that? To the left. As this thing goes to the left forever, where does the function go? He approaches 0. As he goes to the right forever, to the right, he's going to go up forever. So what do we put in the blank? Infinity. There we go. Okay, that's information about this exponential function. Good? Beautiful. Beautiful. All right. Okay, let's do example 2. Yeah, let's do example 2, and then we will do example 3, and maybe we'll skip example 4. No.
Yay.
Yeah, we'll skip
Aw,
example 4. We'll skip
yay.
example 4. Okay? All right, let's do example 3, though. Yes, what? Yeah. Okay, here's the deal. Example 2, let's figure out what's happening to this function. So I'm going to single out. It says my parent function is 3 to the x power. Okay, so we've got a couple things that are happening, a lot of them actually. This plus 4 is doing something, the plus 1 is doing something, the 1/2 is doing something, and the negative is doing something. Woo, that's a lot of stuff. Okay, all right, how is the 4 moving him?
I don't know what the
To the left 4, because plus means to the left. Minus means to the right.
Is he in an exponent?
He is up in the exponent. Yep, the plus 4 is up there with the x.
Still the same.
So it's still kind of the same thing. It's like these are in parentheses. Okay? What's the plus 1 do? Up 1. What's the 1/2 do?
vertical compression.
It's a vertical compression by 1/2. You betcha. So I'm making him short. And what's the minus do? Flips him down or over the x-axis. I'm just going to say flip down. Okay? So this guy right here, normally he should go like this and he should cross at 1 and he should go like this. Yeah? That's what the blue guy is, what he should be. He always crosses through at 1 and he does that. Okay? If I flip him down, he's going to be right here. If I make him shorter though, he's going to be at 1/2 and not at 1 anymore, right? If I make him shorter, he's going to be at 1/2, okay? So now I'm not at this dot anymore, I'm at this dot, and I'm flipped down, so he looks like this. Whoop, like that, okay? Then I'm moving him 4 to the left and 1 down, 1 up. 4 to the left and 1 up. So 1, 2, 3, 4 to the left and 1 up. Guess what? Right there. And he's flipped down. So he looks like this. This is my original starting point that I had before. That's kind of hard. That was a lot of transformations all at one shot.
So the 3 isn't
Okay.
doing anything there.
The 3 to the x power is your parent function. So that tells you the degree of his arch. Like he's like gonna go up faster than what 2 to the x power would be. Because this one is tripling every time instead of doubling. So the 3 itself does not do anything. That's the parent function. Other than the fact that it's gonna be like taller than what a 2 to the x power would be. Yeah, good question. Okay. All right. Do we have to do anything with that? Graph the transformations of the exponential function. The ones that I picked on your homework should hopefully not have 4 steps to them like this one did. I think I only picked like 2 at once, okay? So just be careful with those. Up, down, left, right, vertical stretch, compression, that stuff. This pink one is the one that we were graphing, okay? All right, let's go down to this guy. 3.5 to the x power. That's my parent function. What's happening to him? What's he doing each time?
Nothing. Well, going.
Whoa, it's
He's like a little more than tripling each time, right? Okay, my bacteria is a little bit more than tripling each time if I'm doing that. They want to know how far is he moved up from the original 3.5 to the x power. 3.5 to the x power is going to start here at 1, and he goes like this. Okay, so what's the value of k? How has he moved up or down to get to the new guy? The green one's what he should look like before.
down 2. Is that what it's trying to say?
Yeah, down to.
Is he down 2?
Yeah.
So k would be, the graph has been translated 2 units down. So k equals -2. So the function is 3.5 to the x power. And then -2. Okay, that's what this function looks like. Translated down 2 units, there he is. Okay, I always go off of this point right here, this little dot. He has moved down 2 units, so we're good to go. Okay, good? All right, that was 3. Skip 4, let's go and see if there's some of these other ones that are okay. Oh, here, example 5. I like these. Determine whether these are an exponential growth function or an exponential decay function. Let's see if we can figure this out. Okay, this is 5 to the x power. Is that going to grow every time or is it going to go down every time?
Grow.
Colton, you need to put that away. How do you know it's going to grow?
It's greater than 1.
Ah, if it's a number that's greater than 1, it's going to grow. So this is a growth. Write that next to this guy. Growth. Okay, he is growing. 5 to the x power. What about 2/7 to the x power?
grow because it's in parentheses? Or is it?
What is
What
two?
is the parentheses?
It's less than 1, but it's higher than 0, so it's gonna move. But
This number is less than 1, which means he's going to go down. Like a number less than 1 would be half, right? If I multiply it by a half every time, I'm reducing it. Got it? Okay, so 1/2 or 2/7 is going to be a decay function, is going down in value. Explain to me when we would have an exponential decay function. When will it go down in value?
Value of the
Like stock market, you two both had really good examples. Stock market crashing or the value of a car as you drive it off the lot. Maybe it's $10,000 that you buy it for, and the moment you drive it off the lot, it's only worth like $8,000. Then it will go down the next day to like $6,000. Then maybe a month later, you can only sell it for $5,000, right? Like it's going to go down exponentially and then level off, right? Okay, so that's a decay, an exponential decay. All right, C, is that a growth or decay?
it's a growth.
But it's a fraction.
It's greater than 1.
4/3 is a number greater than 1, so this is a growth. What about 1.05 to the x?
Growth.
He is growing, but not very fast. Barely growing. What about E? Decay. That's a number that's less than 1. Okay? Got it? Okay, let's go. We've done example 6 already.
One more. Yay.
Okay, let's skip 8 and skip 7, but we'll do 6 real quick, and then we'll be done. Okay? Exponential decay functions. We're starting with 1/2 to the x power. Okay? 1/2 to the x power. We just did, Brady and Colton. Brady and Colton. We just did 2 to the x power, yeah? That's doubling every time. 1/2 to the x power is a decay function. So notice the difference. He is going downhill, but what do you notice? He's not going to cross 0, but at exponential growth doesn't either. He still hits that y-intercept at 1. Okay? The only time he's not going to hit 1 is if I move him up, down, left, or right, right? But he still hits at 1 because anything to the 0 power is 1. So if I plot points, he's going and half every time. This is up here at 8. What's half of 8? 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is half. Half of half is 1/4. Half of a fourth is 1/8. And that's how he's going downhill. He is decaying every time. 1/16, 1/32, 1/64, 1/128. Then we can keep going, right? That's what he's going to do. He is going to level off at this guy, which is called the what? The ha. What's the equation for the ha? Y equals 0. Ha, 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 ha. Okay? All right, so we have, let's see, the asymptote, y equals 0. Let's fill this in. The y-intercept we said was 1.
Yep.
Y equals 0 is the asymptote, the domain, left and right. All reals, the range.
Y is greater than.
Is he greater than 0? Because he's going downhill.
No, he's still greater.
But he's still above. Greater than 0 means is he above the x-axis, right?
Yeah.
Even though he's going downhill from left to right, he's still greater than, he's still above, right? Does that make sense? Okay, as x goes to the left, what's happening to him?
Right?
He's going negative.
So approaches 0.
No, as he goes to the left, he's doing what?
He's going
Infinity.
He's going to infinity as he approaches the left, okay? On the right side, he's going to 0. There he is. Fill that in, okay? Exponential growth and decay have the same properties, but in reverse. It's like they're flipped across the y-axis, yeah?
Asymptote.
What?
Y equals
0, Brady.
Y equals 0 is the asymptote.
Got it.
Wait, so is there a vertical one?
No, he does not have a vertical asymptote. He only has a
But is
horizontal
that a
asymptote.
thing?
Yes, not in exponential functions, but vertical asymptotes are used a lot. Yeah, not for exponential functions though. Okay, good. Happy with that? Skip 7 and 8. Get started on these homework problems. Do you guys want some graph paper?
Yes, please.
Yes. Okay. Goodbye, people watching this video.